BTX Technologies operates a dedicated fiber optic lab where we build, terminate, and repair fiber optic cables for the integrator community. We hold multiple fiber certifications and are excited to share some knowledge today on the current landscape of fiber optics. Why fiber? Fiber goes really long range. High bandwidth, of course, you can push a lot more content down fiber than you ever could with copper. Fiber is small and lightweight. It's non-electrical. Fiber is highly secure. It's a lot harder to steal content mid-span in a fiber optic system than with a copper system. And fiber is signal agnostic. Obviously, with copper, you can't just pack multiple signals onto copper unless they all kind of comply with the same gain structure. With fiber, that's not really a problem. There's all kinds of great ways to multiplex signals onto a single piece of glass and then pull it out at the other end.
Fiber essentially is a waveguide. It transmits the light in between two different layers. So when the light actually passes from a lower layer to a higher layer, it actually refracts back into itself at an angle. And this angle creates a zigzag pattern down the center, which is called the core, and it's surrounded by what's known as the cladding. So in the illustration, you can see that the light is actually zigzagging all the way down the middle portion, and it doesn't actually transmit out the cladding. There are several different types of fiber in the industry. The main two we see in our industry are single mode and multi-mode. The differences between them are the core. The outer diameter, which is 125 micron, remains the same among multi-mode and single mode. As far as proximity, it's about the size of a strand of hair. That's where microns are actually measured. It's significantly small. So as you can see, single mode is a lot smaller than the other two multi-modes. The fiberglass construction. So as mentioned, there are two layers of glass. You have the core and the cladding. These layers never come off. When you do termination, they always stay on. The layer is actually coated by an acrylic coating. An acrylic coating or an acrylic coating is the same material used for fake fingernails. Glass, as you know, is fragile. It breaks easily. If they don't coat the glass in this acrylic coating, there's no way to actually spool it and transport it. The glass construction of the different modes, as you can see, there's a single mode and the multi-mode. It's just significantly smaller. So the beam for single mode is more straight, where multi-mode, it does create some zigzags. So multi-mode fiber, there are actually two common core sizes. 62.5 has been around for quite some time. It's known as OM1. However, it's not as prevalent anymore, and I'll get into why. It's mainly due to bandwidth and distances. 50 micron has a couple different names. It's known as OM2, OM3, OM4. The OM stands for optical multi-mode, and the 2, 3, and 4 do play differences when it comes to how long. They all have the same cladding, which is 125 micron, regardless of the core size, and they all are coated in most likely a 250 micron coating. The multi-mode fiber operates at an 850 or a 1300 nanometer wavelength. So I have a chart here that kind of illustrates the distances of these modes and why the 62.5 in particular is really no longer prevalent. 10 gig is what everybody is pretty much installing or higher, and mainly because of the bandwidth we're all consuming. So as you can see on the chart here, as you go up in the OMs, it gets a little bit longer with the distance of a 10 gig. Typically, the OM3 is the one that most of us are seeing in the industry. It goes 300 meters, which is just under 1,000 feet, and majority of the applications are right around under 1,000 feet. So the OM3 is what you're primarily going to be installing. Single mode. So as mentioned, single mode is significantly smaller. It actually has a fluctuation between 8 and 10 micron because it's so small. Majority of the specs you're going to see say 9 micron by 125. They all, as I mentioned, have the same outer cladding. Single mode operates at a different wavelength. It actually operates typically between a 1310 and a 1550, but it does have a range on here. For instance, the telco world, they typically use a 1475, just so they don't have any interference with telecom signals. I also have a chart for signal mode. The big difference on here, you'll notice there is no bandwidth, there is no distance. The reason why, essentially, you could run a piece of single mode cable from New York to LA if you have a powerful enough laser or transmitter, and it would work. There is no signal loss during distance. So you can pretty much run it as long as you need to. So fiber cable construction. So as mentioned, there's two layers of glass. It's the core and the cladding, and it's actually coated in an acrylic coating. And then we have what's called the strength member. The strength member is also known as aramid yarn. The most common name everybody uses is Kevlar. If you're not familiar, Kevlar is the same material used for bulletproof vests. So it's very rugged, it's very durable. That's what makes the cable able to be pulled and manipulated, and in some applications you can stand on it. It's because of that strength member. Of course, all cable is coated in outer jacketing. The outer jacketing varies between a riser, a plenum, a low smoke zero halogen, there's polyurethane, there's polyethylene. There's a whole bunch of variations depending on truly where you're installing it. Connector types. The first one that kind of came around was called the FC connector. And they actually just called it first connector because they really didn't think anything was going to exceed it. So the FC connector actually is a twist-on connector. So you have to thread it on. Really quickly, they realized that threading of a connector is very time-consuming. So they switched over to what was called the ST connector. So the ST connector is known as the stab and twist connector. It actually mimics the BNC. So it was really easy for the audio guys and the video guys to transmit over from a BNC over to an ST because it's the same stab and twist motion. With that said, it's a circular footprint. So getting a whole bunch of circular adapters and a patch panel, you're not utilizing your space the best you can. So the SC connector came out next, which is known as the square connector. This one is a push-pull connector. You can really quickly push in a whole bunch of them and click them right out. There's no twisting, there's no turning. You can get a whole bunch of them next to each other. The LC connector came out next. This is known as the little connector. Essentially, two LCs fit into one footprint for an SC, so it's half the size. This is a truly high definition connector. You can really, really bang out the high density in a rack mount or in a studio center. These four connectors up on top, the FC, the ST, the SC, and the LC are all single fiber connectors. For every one strand, they need a connector. The one down below is known as an NPO. So this is a multi-pin push-on, push-off. It's an ultra high density connector. MPO is the format. MTP is the brand here in the US that most of us use. It comes in a 12 or 24 fiber connector. I wanted to mention some other connectors in the industry. We have been seeing more and more in broadcast and AV. These are ultra rugged, essentially. You have the expanded beam, which uses a lens system. It came around in the military probably about 30 years ago. T-FOCA is a similar concept, very military related. It's just a multi-pin. LEMO is truly a broadcast connector. It is for camera to CCU applications. It combines both power and data. The Nortric optical cons are a rugged system as well. They have a couple different options. They have a data-only connector. They do also have a power and fiber connector, and we'll get more into the options of those as well. So I want to particularly mention two of them that I just showed on the previous slide, the LEMO and the Nortric optical cons. So with the LEMOs, these are truly for high-def applications, for TV applications, broadcast guys. They comply what's known as SMPTE. Anything that's running in a broadcast has to comply with these specific standards. LEMO is one of the best. They came out with Tri-X years ago, and then they migrated over to these combination, which is 2 single mode fibers and 6 copper lines. Out of those copper lines, you get voltage, you get signal, and you get ground. So essentially what this cable does is you're plugging it into your camera, and then it's actually transmitting all the information back to the CCU. The diagram down below kind of shows that pattern. With the Nortric optical con, essentially it is 2 LCs or 4 LCs, and they have a body over it that has a shutter. So the shutter pretty much protects it from dirt and debris or anything getting in there and kind of injuring the ferrule ends. So they do come to 2 and the 4. They also have a 12 and a 24 fiber. That is usually utilizing a MTP. So it's actually an MTP connector that is wrapped in that housing. The optical con also has a SMPTE connector, very similar to the LEMO. It's got the 2 single mode fiber strands and the 6 copper lines for CCU and camera applications. I did want to mention one thing with the noise stroke optical cons. Not everybody can terminate these. They are only several people, 7 of us actually. BTX is one of them. They're known as COCAs. They can actually put on the connector, clean them for you, repair them for you. So I just wanted to mention the noise stroke optical cons. So there are 3 main termination options that we use in the industry. Epoxy base has been around since day one. It's known as puck and polish. I have an illustration there of somebody holding a low polishing puck with a connector in it, and they're running it over what's very similar to sandpaper. It's known as polishing paper. So it's just removing any dirt, debris, or epoxy on the end of that. The picture in the middle is a high-end polish machine. You can do anywhere from 12 to 24 connectors at a single time. And then on the end, we have the interferometer scope. This is a high-end 3D microscope. It looks at the geometric end face ferrule of the connector, and it'll pinpoint exactly if there is dirt or divot or even any oil, it'll actually show up on there. The biggest pro is it's factory terminated, it's tested, it's certified by a professional, and when you get it, it is plug and play. You plug it in, it'll work, you don't have to worry about it. The biggest con typically with epoxy base is the lead time. You know, if you're asking for a custom assembly, most likely you're going to want a custom length, 52 feet or something unusual. They're going to make it for you. Termination 2, so this is the mechanical base. Essentially what it is, it's a pre-cleaved, pre-polished connector, and it's ready to accept a pre-cleaved, pre-cleaned piece of fiber on the other end. The biggest pro, I would say, is it's easy to use. You know, anybody can watch a couple-minute YouTube video and figure out how to put these on. There are field termination kits, there's tools, they're really, really easy. The biggest con is the longevity. You know, I would say roughly 1 to 5 years longevity on these, really depending on your environment. So the last, which has also become very popular in our industry, is fusion splicing. So fusion splicing is using 2 pieces of glass, and it's actually heating it together with a electrical arc. As far as some of the pros and the cons, a pro is it is definitely in the field. It's quick. It's a low production shop, you know, attenuation, as far as you're probably looking at maybe a dB if you're doing a fusion splice versus mechanical splice, you're looking at 3. So it's really quick and easy. The con is, of course, the cost. You know, you're looking at a $3,000 machine. The connectors themselves are not cheap. They're anywhere from $14 to $18, and typically they're one and done. So that's where the skill set kind of comes into play. Belden actually does have an option where you can use it multiple times, which is wonderful. So as far as applications, fiber is used in a wide variety of applications, and Chris Mahalso is actually going to go through those options for you.
I split it into 2 basic categories. First one's going to be permanent installation fiber, whether it's in a structure, outdoors, or in a manufactured product. And the other would be temporary deployment. That's going to be your rental stuff, your severe environment, anything where handling is going to be consideration. So installation grade fiber can range from zip cord, which is the stuff you just see on the little jumpers that you can buy anywhere. Distribution fiber is going to take those individual fibers and put lots and lots of them under a jacket. Breakout is going to take an outer jacket and put it around each fiber so you can break them off and have something still workable that's not going to just fall apart because it's so small, but then they're all in an outer jacket, kind of like old multi-pair audio snakes were. Loose tube refers to anything that has water blocking technology under the jacket. It's not actually loose in the tube as the name might imply, but it indicates that there's something in there, either a gel or a water blocking tape or something that prevents water from penetrating that system. Aerial we don't deal with a whole lot, but as you can see, there's a high tensile member there that allows you to suspend it between poles or buildings, just like old telephone pole application. And then last is armored. And with installation grade fiber, when we talk about armor, we're talking about protecting it from the installation process or for things that might happen to it over time once it's installed. one product we wanted to bring to your attention is this really cool new technology called Tiny Fiber. The comparison we're showing here is the old way and the new way. And the old way, of course, is much bigger, much more expensive. Tiny Fiber fixes all those problems. It's smaller, cheaper, lighter. It's got a stainless steel spiral shield, and it still meets all the same protection standards. With tactical fiber, now we're talking about more of the severe environment stuff. Yeah, you're still going to see an armored option, but it's armored because of the handling and because of the, the impact of people touching it and working with it, perhaps stepping on it or running over it. So it's a little bit different approach. Sure, you've still got breakout fiber. You've still got distribution fiber. Loose tube, yeah, definitely. You're also going to have something a little new, composite, which is when you've got fiber and copper under the same jacket. Now with permanent installation, it's really easy to do a run of fiber and a separate run of copper because it doesn't matter. But when you're trying to pull this out onto a football field or do something that's dragged behind a camera, you don't want two cables, you want one cable. So the idea is to have everything under one jacket. And the last one is rodent deterrent. I swear I'm not making this up. This is a thing. This is an ongoing problem, and rodent deterrent is accomplished by adding what's called a bittering agent to the outer jacket, which is exactly what it sounds like. It makes the cable not taste good to the rodent. Now I'm going to go through some industries and some markets where we see fiber a lot. On each of these slides, you're going to see over to the right, I've mentioned the connectors that are most common in those applications. But we really want to mention data centers because they're sort of the backbone of everything going on. And data centers, you're going to definitely see a lot of LC connectors and a lot of MPO connectors. That's a big important part. Of course, now we see fiber in residential, not unusual at all anymore. And last thing here is a kind of a neat picture, I thought. Connecting continents. This is a picture of the interior of a ship hull that's been purpose-built to act as a giant multi-hundred-mile cable deployment reel as Google crosses the Atlantic to drop their dedicated fiber line to the floor of the ocean. They're essentially data centers, and of course they're going to have all the same stuff you'd see in data centers with a couple extra things because there are cameras and there are specialized audio-video equipment in broadcast facilities. So optical con and SMPTE will be there too. One of the other big reasons they like fiber in broadcast facilities is to deal with ground differentials in electronic gear. Chasing a hum can be one of the most frustrating things in the AV industry, and often you can break that ground differential hum by connecting with fiber because now there's no electrons moving. Next, we'll go into enterprise. Plenty of corporate environments now house their own data centers. Also, education, of course, huge amount of data changing hands. Government, clearly. And again, that's information that is secure. So we want to use fiber for that criteria, of course. And retail, even if your point of sale isn't connected to some huge on-site IT rack, there's a very good chance that the headquarters of that company is collecting the point of sale information over a fiber-driven system. Medical occupies a couple specific categories. In the clinical side, there's lots of interesting sensors and test gear now. This is a picture of a bone loss monitoring system where they actually put sensors under the skin of the subject, and then they access those sensors with a fiber optic interconnect. In surgical, you're taking it to a really literal place where the fiber is actually in the body of the subject. In this case, with endoscopy, this is all something we've kind of become familiar with. But whether it's emitting light, collecting video data, this is just the best way to do it. And then, of course, you've got the more utilitarian stuff, data collection, and billing for that matter. Of course, there's a huge data requirement behind all that. That's all going to be data center stuff. And again, HIPAA requirements make those very, very secure applications. So using fiber for that is kind of obvious. Industrial can, again, mean a lot of things, but just some examples, machine vision. God, BTX used to build tons of copper machine vision assemblies so little cameras could monitor what robotic arms were doing. Well, that's still a technology everybody uses, but now they're often using fiber because it's easier over the long distances and it's smaller and it's more lightweight. Communications, this could mean a lot of things, but look at this example, an oil rig. That thing has to get towed out there, and having things light and small and long distance, of course, are really big factors with something like that. Control rooms, again, this is a market we do a lot in. These control rooms are often connected to the manufacturing facilities or oil rigs or whatever, and all that information is coming in over fiber, but also in the facilities, a lot of this stuff is connected with fiber just to take advantage of the low latency and the high bandwidth. And transportation, whether you're talking about actual traffic controls or traffic sensors, clearly if you're going to monitor traffic on a 200-mile run of highway, if you're lucky and you can do it wirelessly, great. But if you're doing anything with infrastructure, you're going to have to use fiber because the distances are just so long, and you don't want to incur any of that latency when that data is coming back to the head end, whatever it is. So fiber is very common there. And in these environments, you're going to see the optical cons and some of the ruggedized connectors too, because often these are out where the action is, not necessarily back in a controlled environment. Wind turbines are a growing industry, and because of the vibration present in these environments, the ST connector has become the go-to for wind turbine monitoring. Now we get into broadcast. ENG is the abbreviation given to electronic news gathering. Anytime you're doing field news gathering, and the cable hanging off the back of those cameras usually is going to be a LEMO SMPTE cable, the ones Jessica was talking about earlier. Sports, obviously, same kind of application. This is actually a picture of the Tampa Bay Rowdies soccer stadium. BTX with an integration partner did this system where it was going to be half SMPTE and half optical con. Ultimately, they went with 100% optical con on our recommendation so that they'd have a little bit easier field termination when they were installing the panels, and this worked out great. Remote trucks, you're going to see these outside any sort of sports event or concerts or whatever, but if you open those doors down under the bays there between the wheels, you're going to see lots of ST connectors, SMPTE, optical con, because to hook up with those facilities, usually the truck bay they're parked at is equipped with all that stuff too. And last, I just kind of mentioned streaming quickly. I mean, a lot of the desktop streaming we're doing, even at professional events, might be copper connected on the equipment we're actually using, but obviously it turns into fiber very quickly after that because the companies like Wowza, Livestream, or some of these big streaming companies are effectively data centers dealing with tons of content from tons of clients going out to perhaps thousands and thousands of people watching the stream. So that's a lot of content. Couldn't do it with copper. Got to use fiber for that. This might be a new term to some of you, but IMAG is short for image magnification. This refers to any time you've got a live camera shoot where you're putting that image on a large format display. The touring market, again, if you go to see that Kenny Chesney concert, whatever it is, there's a good chance that you're going to spend a lot of your time looking at the LED wall because it's so much bigger than Kenny on the actual stage. BTX supports a lot of these rigs. This is a shot of the Katy Perry tour that we supported with a partner company last year. Corporate events, same kind of application. You're shooting a presenter or presenters and putting it up on a large format display because that keynote might have hundreds and hundreds of people in it. Want to make sure everybody can see what's going on. And of course, sports mentioned here again. When you're doing these massive wraparound LED walls, this is the new facility they built in Atlanta. Obviously, getting that far distance-wise requires fiber. Having the low latency, and there's nothing worse than hearing the other team score and then not seeing it on the display until 4, 5, 6, 10 seconds later. You can avoid all that stuff by using fiber, and of course, that's what they did here. Event production is a really broad term. Lighting, often you'll see ST connectors, optical con, sometimes LCs and SCs. It's going to be not necessarily light emanating from fiber, but the control systems, whether it's DMX or ArtNet, often is traveling over a fiber optic system. Sound, this is actually one of the few places you're going to run into the HMA connector. If you see that on the upper left there of my connector chart. HMA is an expanded beam hermaphroditic connector. You don't see it a lot, but there's a console manufacturer called Digico, and their fiber platform they call Opticore, and it uses an HMA connector. So there's a picture, some partners of ours that use a lot of Digico, and we build a lot of HMA for that. Video is a broad term, but whether you're just distributing it around a ballroom, doing IMAG, recording it, streaming it, of course you're going to see any of a number of these connectors, and you know, it's very similar to what we were talking about with IMAG. And last, backhaul. Some of these facilities, whether they're concert halls, stadiums, performing arts centers, certainly convention centers, they're physically large facilities, and they've usually got TVs hanging everywhere. So it's very common to want to take that content happening in that ballroom or that hall and distribute it out to that facility locally, and that's referred to as backhaul. But when you're talking about, you know, maybe Orange County Convention Center, you know, we did all of the fiber and digital signage there with a partner in Orlando. Obviously, you got to do fiber. There's just no way to reach all the different ends of that facility. If you've ever been there for Infocom, you know how huge it is. So backhaul is kind of a permanent install example, but not really, because you got to connect it to the live event that's going on. Military and space, I mean, look, we don't get to see exactly what these guys do with our products all the time, but just to quickly mention some of the ones Jessica touched on, this is really the only place you're going to see the T-FOCA connector. Military communications, you know, whether you're trying to set up a forward command position and talk back to some other station, or even just get comms around a corner, up a staircase, whatever it is, fiber is certainly the way to do it. And combat surveillance, I mean, certainly slipping cameras under doors and around corners has become very common, and you got to use fiber for that if you can. We used to use copper, not anymore. Space exploration. I won't claim to know what they're actually doing over at SpaceX and Blue Origin. I'm sure it's really cool, but there's no question if you're sending a spacecraft up, you got to be considering weight, space, physical space, and electrical interference. And fiber, of course, meets all three criteria. It's light, it's tiny, and it's not going to interfere with critical electrical systems. I do want to mention quickly active optical cables. These are purpose-built around particular formats. In this example, you've got permanently terminated HDMI end-to-end cable. It can go up to 320 feet, though. It is armored fiber, as you can see in the little diagram, and it's also protective caps. So it's really ruggedized, very, very hard to break. High flex, small bend radius, you can certainly go around corners and wrap it without destroying it. It is a hybrid cable. This actually costs less than a good quality Cat5 extender, but more importantly, it eliminates tons of fail points. And this is not the only way that we offer this either. So we've got HDMI with removable ends, HDMI with permanent ends, DisplayPort with permanent ends. And the last one would be the USB extender. Same technology, but USB 3.0 does not go as far. You're talking more like 50 feet instead of 320 feet. But that's a great solution if you're trying to take a webcam and position it further away from the computer in a large space. A couple of people asked whether BTX offers certification training. Jess, I think you'd probably be good to speak to that.
With fiber in general, you truly don't need a quote unquote certification. There are, of course, fiber certification trainings. It just pretty much means that you went through the standard Telecordia recommendations. We do not offer the certification training, but honestly, we'll come and train you on whatever you need. Fusion splicing, how to use an OTDR, how to use a mechanical splice. We do a lot of on-site customized training.